Greetings, everyone. We are going to do the second part of our work with pedigrees, and we're going to do a sex-linked trait. The first pedigree that you created was based on an autosomal condition, and so this pedigree that you're going to create is on a sex-linked trait. Now, there is the standardization of how we tell the difference between males and females. Of course, males are squares. If the male is healthy, so a healthy male is an empty square. The shaded or colored in square is an affected male. And then the half shaded is a carrier or heterozygous male. And then the standardization for females, females are circles. The empty circle is a healthy female. The fully shaded or fully colored in circle is an affected female. And then the half shading is the carrier female. Now, you'll notice in the first pedigree, I do not do this. I do not do the half shading. So we had heterozygotes, we had carriers in our first pedigree. They were here and they were here. But you notice that I did not shade them in. I don't shade them in because I want you to understand how we know that they are carriers. How do we know that these two individuals are heterozygotes, right? If I shade them in, I'm giving it to you. So I teach you at a higher level than what is usually given on a pedigree chart. So that way, when you take your IB and AP exams, or you take a state-sponsored test, and they shade these halfway in, then those are actually easier for you because you've been trained at a higher level. So let's take a look then at what we're going to do with a sex-linked pedigree. Okay? So what we're going to tackle is hemophilia. Now, with sex linkage, you have two choices. You have color blindness and you have hemophilia. So hemophilia is a sex-linked recessive condition. So if it's sex-linked, that means it's attached to the X chromosome when we write it out. So our pedigree would just be covered with X's and Y's. And then the H's, the big H will be for healthy. And then the little h will be for hemophilia. Like such. Okay? So last time we drew the female first for the P generation. So this time we'll draw the male first. It doesn't make a difference. So we have two healthy parents. And then in our F1 generation, I classically draw 3. So last time we went girl, girl, boy. So this time, let's go boy, boy, girl. And let's say their first son is affected. Okay? And then this affected male reproduces with a healthy female. Here's your F2 generation. And let's say they have, let's say 2 daughters. Both of them will be unaffected. Fine. Then this female in the F2 reproduces with a male. Then we're going to get a 4th generation here. And let's give them 2 children. And let's give them also a male and a female child. And let's make the male affected like such. So then over here, this female is going to reproduce with a healthy male. Let's give them 1 daughter and see how these two individuals, actually these are all cousins, see how they line up here on the same generation. And then let's make her reproduce. Let's make the individual coming into this family affected. She reproduces with an affected male. And let's have them produce an affected daughter, like such. Okay? So let's be sure that you're comfortable with the generations. I am throwing out those terms, and I want to be sure that you understand. This is your P generation, or your parental generation. And then Latin for offspring is filial. So this is a filial generation, this is a filial generation, and this is a filial generation. Well, how do you tell the difference between each filial generation? This is F1, this is F2, and this is F3. Not complicated. What we call first filial, second filial, and third filial. Cool. All right, so here is our pedigree. So, since we're dealing with a sex-linked condition, put X's and Y's all over your pedigree. Don't go too fast. Take your time. Be sure that you're identifying females as females and males as males. We're not talking about gender here. Gender is based on the expectations of your culture based on your sex. Sex is male and female. So sometimes for Halloween, for the IB group, I will dress up as, let's say, a Disney princess. And it's pretty funny when I show up in a dress and heels. Now, why that's funny is what is expected of a male in our culture, my sex, is not to wear a dress and heels. So the gender requirements of me being male in our society says that I'm not supposed to usually wear a dress to work and shoes. So it's pretty silly. Whereas when you hear of people saying that, oh, we're pregnant, and so we're going to have a gender reveal party. As a biologist, that's not how we speak. It's a sex revelation party. You are revealing the sex of the offspring because the offspring is either male or female. So in biology, you will never hear us talk about gender because gender is based on what society expects of your sex, whether you're male or female. Fine. So let's talk about the sex of all these individuals. So male and female. He's a healthy male. Since he's healthy, he has a big H attached to his X. She is also healthy, which means she also has a big H attached to her X, but she's a female. So she has the advantage in sex-linked conditions that she can hide things, or maybe not, on her X. Is she hiding? We don't know. Well, if you don't look at her children, we don't know. But the minute you look at her children, you'll see that we can find out very quickly. So the two healthy parents have a sick child. Again, think of the genetic counselor. Healthy parent, sick child. Whoa, where did this sick baby come from? Well, of course, if you have a sick offspring, usually those genetics came from and can be identified with the parent. Sometimes not, but usually yes. So with hemophilia, it's easy to identify. So this son here has a little H attached to his X. Well, where did that little H come from? Since both of his parents are healthy, this little H was being hidden from by his biological mother, like such. So she's a carrier. She's a heterozygote. Okay? So then, on the last pedigree, we went left to right. So on this one, we're going to go top to bottom, right? So let's take a look then at this male then reproduces with this healthy female. Since she's healthy, she has a big H. At this point, not looking at her children, we don't know what her second allele is. All right, so they have two healthy daughters, okay? Well, if the daughter is healthy, she's a big H. Well, what's her second X? Do we know? Oh, we definitely know, because the only thing that her biological father has to give her is the little H, like such. Okay? So as the female, she carries two X's. One X came from her biological mother, and the other X came from her biological father. So her sister is healthy, same thing, big H. But what is her second X? Well, just like her sister, right? The biological father, the only thing he has to offer is his detrimental allele. So she is also little h. So these two females are carriers, and you will see people shade halfway in. Okay? All right, so this female reproduces with a healthy male. If he's healthy, therefore on his X is a big H. Okay? So then this healthy female and this healthy male produce two children, a healthy female and a healthy male. All right, so a healthy female, of course, is big H. But do we know her other allele? Don't know. Okay, because if she got her big H from her biological mother, she could have picked up a healthy H from her biological father. It's also possible, though, that this big H came from her biological father, and this could be a little h from her biological mother. Again, this would be the genetic counseling that you would give this female, and you would tell her, you should probably be screened because we don't know what you are. Okay, she then has a brother, and he's an affected male, and he was not so fortunate. He had a 50-50 chance on the X he got from his biological mother. He could have picked up the dominant H, the healthy H, but he didn't. He picked up the detrimental recessive H. So even though we've worked through these 4 generations, we still don't know what she is. So just because you have children doesn't always tell you your genotype. Sometimes it does and sometimes it doesn't. Now, the advantage that you and I now have is that we can have genetic screens and go to a lab, and they will, for a fee, they will screen you and tell you whether or not you carry hemophilia as a female. All right, so let's go back up to the F1. This female here, this male here, he's healthy, therefore he has big H. Easy. All right, let's take a look at the right-hand side. Female, healthy. Since she's healthy, big H, don't know. Male, healthy. Since he's healthy, big H. Healthy female, healthy male, has a healthy offspring. She is healthy, therefore she is big H. We don't know her other allele. Okay? Healthy female, affected male. He's sick with hemophilia. Therefore, he has little h. All right, a typical female, a healthy female, reproduces with an affected or sick male. They have a sick female. This is pretty uncommon. Only 1 in 10 hemophiliacs is female. So then, if she's sick with hemophilia, that tells us little h, little h. See, she has to get 2 copies of the detrimental allele to be a hemophiliac. He only needs 1. It's the advantage of being female. But then we can work backwards, because this H, we know that this H came from the biological father. It's all he has to offer. Well, where did this one come from? Boom. That tells us this one. Well, then hold it. Where did she get it? This tells us here. This is what genetic counseling is all about, okay? This is where you sit down as the genetic counselor, you talk to the members of the family, you collect their history, and based on your knowledge of genetics, you create a pedigree chart. So I'm going to ask you to create a pedigree chart, okay? But you're going to create, this is going to be your second pedigree chart. Create a sex-linked pedigree. Oops, see if I can spell pedigree. There we go. Create a sex-linked pedigree. All right. Now, this is going to be 4 generations. 4 generations. Now, if you really want to get into this and you want to do more, do it. Be creative. If you want to do 4, do 4. All right. Now, just like earlier, when I said go left to right, all right? Now, we used Roman numerals on the autosomal. You could also number these. 1, 2, 3, 4, 5, 6, 7. Notice how I'm going left to right. 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? If you wanted to use letters, A, B, C, D, E, F, G, fine. Roman numerals, fine. All right? And then come down here and be, all right, tell me about individual number 1. Tell me about individual number 2. Tell me about individual number 3. Individual number 1 is male. Individual number 1 is male. He's healthy. So there is his phenotype. Then give me his genotype, okay? So it's phenotype, phenotype, genotype, all right? And then you would do that for every individual in your pedigree, whether you do 1, 2, 3, A, B, C is completely up to you. So by Friday, if you could give me 2 pedigrees, 1 autosomal 3-generation pedigree, P, F1, and F2, and then give me a sex-linked pedigree, 4 generations or more, P, F1, F2, and F3. Then show me your work as a PDF. If you could post that by Friday, that would be fantastic. And as always, if you have questions on this, text me, call me, Jupiter, email, messenger, however you want to get a hold of me. I am happy to help. We'll talk to you guys soon.